students. So as we have studied all the logic gate characteristics related to all those gate logic families, like there were different logic families as I divided them into bipolar and unipolar devices, and in bipolar we had RTL, DTL, TTL, ECL. We studied all these, and its examples were DCTL, I square L. And the next was CMOS, and CMOS basically self covers the MOS. That is, MOS is made up of PMOS and NMOS. CMOS is basically the combination for PMOS and NMOS, right? Actually, CMOS is basically the modified version of MOS. So that's why in this comparison table, I have included only the CMOS. CMOS is mainly used for battery operated applications, and that is and why? Because इसकी जो पावर डिसिपेशन होती है ना, वो बहुत ही कम होती है, मतलब बहुत कम पावर डिसिपेट होता है. इसलिए मॉस को भी डोंट यूज इट. इनिशियली मॉस ही लाया गया था, बट विद टाइम मॉस से हम सीमॉस पर ट्रांसफर हो गए, क्योंकि मॉस में पावर डिसिपेशन हो रहा था. पावर डिसिपेशन से क्या होता है ना, कि अगर जैसे कोई बैटरी, जैसे तुम्हारा फोन है, लैपटॉप है, डेस्कटॉप है, क्या पावर डेस्कटॉप नहीं, लैपटॉप है, पावर से चलता है. मतलब एक बार चार्ज कर लिया तो जितनी जल्दी पावर डिसिपेट होगा, पावर वेस्ट होगा, हमें वापस से चार्ज करना होगा ना. तो सीमॉस इसलिए हम यूज करते हैं ताकि पावर ज्यादा टाइम तक रह पाए. बैटरी से चलने वाली चीजें उसके सीमॉस लगता है. इफ यू कैन चेक इट आउट, तो यहाँ पे we use CMOS. Now this is the comparison table where I have written down the parameters और उसके basis पे different gates को we are comparing. Yes, so firstly let me rename these. DCTL is actually direct coupled transistor logic, and I square L is integrated injection logic. Okay, so देखो सबसे पहला parameter is basic logic gates. So what are the basic logic gates which can be drawn using all these logic families? Is RTL uses NOR, DTL uses NAND, TTL is NAND, ECL का भी OR और NOR operation होता है. CMOS में NOR and NAND both operation. Then in DCTL we have NAND, and I square L uses NOR. This is the basic logic gate for all these logic families. Now the components that are being used. In RTL we use transistors and resistors. DTL में भी diode transistor logic में we use diode and transistor. TTL transistor logic. So of course here transistor is the main component, but we do use resistors. फिर ECL में we use resistors and transistors both. CMOS is operated on PMOS and NMOS. CMOS is complementary metal oxide semiconductor, and it uses both PMOS and NMOS in complementary fashion. Now DCTL uses again resistor and transistor, and I square L, okay, integrated injection logic uses transistor. Now this is power dissipation. Actually here third point is I written wrong earlier. This is power dissipation, okay, and we measure it in milliwatts, right? So RTL has the value of power dissipation as 30. DTL somewhere lies between 8 to 12 milliwatts. TTL has 10 milliwatts of power dissipation. ECL lies between, that has the maximum power dissipation of 40 to 55 milliwatts. Now again see here. CMOS has the lowest power dissipation of 0.1 milliwatts. Please just imagine कि कितनी slowly ये power dissipate करता होगा. तो how much capacity it has to hold the storage value, capacity value को charge करके रख सकता है. Now DCTL has a value of 30, and I square L lies somewhere in between 5 to 25 milliwatts. Okay. Now next is propagation delay. Now and it is measured in nanoseconds. Now as you know, propagation delay is related to speed of the operation. Lower the value of propagation delay, higher will be the speed, right? So RTL has the speed of 12. This is 12. Okay. Now DTL has the propagation delay of 30 nanoseconds. TTL has 10 nanoseconds. Now see, ECL has the, as you can see already here, ECL has got the lowest propagation delay. That means its speed is highest. And as I taught you earlier in ECL lectures, that ECL it does not let the transistors drive into saturation. ये क्या करता है, हमारे transistors को saturation में जाने ही नहीं देता. इसीलिए इसकी speed fastest होती है. Speed fastest होगी मतलब propagation delay कम. तो देखो यहाँ पे propagation delay क्या है, कम है. अब यहाँ 2 के सामने I have written 10K and 0.7 के सामने I have written 100K in brackets, right? इसका मतलब है the resistors value that we are using, that is just been denoted here. Now CMOS में, but basically the value that you need to write is 2 only. 2 या फिर 0.75 both, मतलब actually almost we use 2 only. If we are using the resistors of 100K तो 0.75 की हो जाता है, but yeah 2 actually is very low propagation delay. वो अपने आप में बहुत कम है, क्योंकि बाकी सबको अगर देखो तो देखो कितनी ज्यादा वैल्यूज. Now CMOS has the propagation delay. CMOS obviously has power dissipation very low, but इसका propagation delay थोड़ा ज्यादा ही होता है. It has 70. Now DCDL has the propagation delay of 10 nanoseconds, and I square L I somewhere between 25 to 25 minutes. Range is too large. Now the noise margin. Noise margin is what actually the noise, the capability to tolerate noise, right? RTL का बहुत ही poor होता है. DTL is noise margin is quite high, मतलब काफी noise it can tolerate. TTL is medium. ECL का भी noise margin बहुत low होता है, तो ज्यादा tolerate नहीं कर पाता है noise को ये. CMOS again has high noise capability, noise tolerance capability. Now DCTL is again very poor with noise margins, and now I square L is high. Now fan out, the maximum number of gates that can be driven, right? The maximum number of gates RTL में बहुत low होता है, which is 4. TTL में is medium up to 8. TTL is high, yes, it can drive 10 gates. Then ECL is very high, 25. Now CMOS is the one, again he is stealing the show with 50 gates that can be driven, which is extremely high. So CMOS is very much used driving the gates, similar gates, say extra devices हमारे कम हो जाती है use. Now DCTL has again low fan out, and I square L is lies somewhere between 8 to 11. So this is the comparison table, and if you are being asked the exam, then you need to draw this table. और एक marks में the most important point is power dissipation and propagation delay. These two are एक नंबर में पूछे जाते हैं कि किसका highest है किसका कम है. तो power dissipation सबसे कम किसका होता है, CMOS का. और propagation delay क्योंकि ऐसा कम क्यों पूछते हैं ना, क्योंकि हमारा क्राइटेरिया ये होता है कि power dissipation कम होनी चाहिए, तो सबसे कम किसका होता है, CMOS का. और propagation delay हमारा कम होना चाहिए, क्यों, ताकि हमारी स्पीड ज्यादा हो. तो प्रोपगेशन डिले के टर्म्स में या फिर स्पीड के टर्म्स में स्पीड सबसे ज्यादा किसकी होती है, ECL की, और इसकी प्रोपगेशन डिले से कम होती है, which is 2 nanoseconds. So this is about all the comparison of the logic families, and this is where all the unit 3 ends.